Okay, so number 2, we are going to express cos 2x and sin 2x in terms of cos x and sin x. You know here we can use double angle. We get cos 2x in terms of sin x, in terms of cos x. And also we can use double angle, get sin 2x in terms of sin x and cos x. But let us try to see how we can use complex numbers. We know that, remember by the Moeller theorem, when you have cos x plus I sin x power n, this is cos nx plus I sin x sin nx. This is the Moeller's theorem. So here it is by the Moeller's theorem. So here it is by the Moeller theorem. So now, which means that cos x plus I sin x power 2, the answer is cos 2x plus I sin 2x. Then, what about by binomial combination? What about by binomial theorem, where we have cos x plus I sin x power 2? So what is the answer by binomial theorem? How do we get that one when you use binomial theorem? Remember, when you use binomial theorem, when you have a plus b squared, it is a squared plus 2ab plus b squared. So which means that cos x plus I sin x power 2, our a is cos x, our b is I sin x, which is cos squared x plus 2 cos x I sin x, then plus b squared, which is I sin x squared. So which means that cos x plus I sin x squared, the answer is cos squared x plus 2I sin x cos x, then minus, remember I squared is -1, minus sin squared x. So real part on one side and imaginary part on one side. So this is cos squared x minus sin squared x plus I into bracket 2 sin x cos x. So remember this one, by using binomial theorem, this one, the answer is cos 2x plus I sin 2x. So which means the answer of this one is cos 2x plus I sin 2x. So remember, for the equality of complex numbers, the real part equal to the real part and imaginary part equal to the imaginary part. So which means that cos 2x equal to cos squared x minus sin squared x. Then sin 2x equal to 2 sin x cos x. So that's the answer. Like here, we can express cos 2x in terms of sin x only, or cos 2x in terms of cos x only. Or you can stop from here. It is according to the question. So the question says that express cos 2x and sin x in terms of cos x and sin x. So our cos 2x is equal to cos squared x minus sin squared. So we can say that, but here for sin 2x, the answer is this one. We can say cos 2x equal to cos squared x minus, you know that sin squared is 1 minus cos squared. So which is cos squared x minus 1 plus cos squared x. Therefore, cos 2x equal to 2 cos squared x minus 1. With sin 2x equal to 2 sine x cos x. Cos x. So this is the answer. Then from there we have how solving equation a cos x plus b sin x equal to c. For a is different, a and b are different from 0. How can you solve equation which is in that form? For example, when you have a cos x plus b sin x equal to c, the model our z is a plus bi. You see z, the coefficient of cos a, coefficient of sin b. Then the magnitude of z cos x minus angle equal to c. So what is this angle? This angle is the argument of z. So this is the formula to do that. So this is c. And this c is this one. Examples. So this is the formula to use when you are solving equation like that. Examples. So we have example 1. Use complex numbers to solve. Use complex numbers. Use complex numbers to solve use complex numbers to solve. We have a cos x minus sin x equal to -1. So we have b. We have b. Our b is √2 sec x plus tan x equal to 1. So let us try to solve, to do these examples to understand how to use this formula. Okay, now let us solve those examples. Let us start with a. See a, we have cos x minus sin x equal to -1. When we compare with a cos x minus plus b sin x equal to c, you see that from there you know that our z equal to a plus bi, then the magnitude of z cos x minus angle equal to c, where angle is the argument of z. So when you check there, you see that our z will be equal to 1 minus I. That's our z, because you see we have a minus here. So what is the magnitude of z? It is √1 squared plus -1 squared. So the magnitude of z will be equal to √2. So we're going to find the argument of z. We start with tan alpha, which is equal to b over a. You remember that we don't use negative signs, we use positive sign. So tan alpha equal to 1 over 1. Tan alpha equal to 1. So alpha is tan inverse of 1. And tan inverse of 1 is pi over 4. Alpha is pi over 4. So then we are going to consider quadrant where that z is located. So our a is positive, but b is negative. So it is here in the first quadrant. And you know when it is in the first quadrant, in the first quadrant, angle equal to negative alpha. So meaning that our angle, which is argument of z, will be negative pi over 4. So we come back in this formula, the magnitude of z cos x minus angle equal to c. So the magnitude of z, which is root 2 cos of x minus pi over 4 equal to c. What is our c? Our c is negative 1. Our c equal to negative 1. So the answer is negative 1 here. So mean that this is the cos of x plus pi over 4 equal to negative 1 over root 2. Remember, cos is positive, cos is negative in the second quadrant and the third quadrant. So mean that x plus pi over 4 equal to cos inverse of negative 1 over root 2. So what does it mean? It means that x plus pi over 4 equal to, you know that cos of inverse of root 2 over 2, it's supposed to be 45, but it's in the second quadrant, which is, if it is 45 degrees, and it is in the second quadrant, which is here, from here to here, it is 135 degrees. To be 135 degrees. So which is 3 pi over 4. So then now, cos inverse of 1 over root 2, the answer is 3 pi over 4 plus 2k pi. Or, because it will be in the second quadrant, or it will be in third quadrant. So it will be 3 pi over 4. It's supposed to be, because it is 45, how can you convert 135 into radian? So we notice angle divided by 180 degrees equal to radian over pi. So 135 divided by 180 degrees equal to rad divided by pi. So by 5, one take by 5, 135 divided by 5. We put there 2, 10, 3, 5, 7, that is 27. By 5, you get 27 degrees over, what is 180 divided by 5? That is 3, 15, that's at 6. So get 6 degrees equal to rad over pi. So by 9, 3. By 9, 4 equal to r over pi. So rad, you get 3 pi over 4. Yeah, it is 3 pi over 4. Good. So it is 3 pi over 4 plus 2k pi. So now, in the third quadrant, if there is a circle here, and this is 45 degrees, so from here to here, it is 180 degrees plus 45, which is 225 degrees. So how can you convert 225 degrees into radian? You get 225 degrees over 180 equal to rad over pi. So we divide by 5. By 5 here, 225 divided by 5, 420. 2, put there 45. So it becomes 45 over 36 equal to r over pi. So by 9, 5, that's 5 over 4 equal to r over pi. So r becomes 5 pi over 4. So now it will be 3 pi over 4 plus 2k pi and 5 pi over 4 plus 2k pi.